nitrogen. It's the same kind of nitrogen you're breathing from the air around you, just in liquid form. But according to Hollywood, it can slow down Terminators or shatter human heads. And according to my middle school science teacher, it can also bring joy to children around the world. Maybe you have memories of someone coming to your classroom and showing off some cool tricks with liquid nitrogen, like smashing a frozen racquetball or mixing it with cream and sugar to make ice cream. But whether we're talking about fictional murders or real-life desserts, liquid nitrogen just gets the job done because it's super cold, roughly negative 196 degrees Celsius. At sea level, that's the temperature at which molecular nitrogen changes from a gas to a liquid, or vice versa. And over the years, scientists have found a bunch of uses for liquid nitrogen that are way more impressive than any special effect or classroom demonstration. Okay, using liquid nitrogen to freeze dirt might not sound impressive at first, but frozen dirt can be super useful, especially if you're digging a big tunnel, because tunnels have a tendency to collapse unless they've been fortified, and freezing the ground can keep a giant underground hole stable while workers build permanent structures like tunnels for cars or trains and vertical mine shafts. Or maybe you don't need to dig a big hole. Maybe you want to cut off or redirect contaminants or groundwater. Freezing specific parts of the ground can help you do that too. No one's pumping liquid nitrogen directly into the earth or anything though. Instead, they insert pipes into the ground and then run liquid nitrogen through them, freezing the nearby ground. Of course, you don't have to use liquid nitrogen to freeze dirt. It can also be done with brine, which is just super salty water that can stay liquid at way colder temperatures than regular water. And brine generally is the cheaper option, but liquid nitrogen has its advantages. If you have a leak, you don't have to worry about a harmful compound leaching into the ground, because remember, it's literally the same stuff that's above the ground in the air. And not only are the freezing systems quicker to install, but because liquid nitrogen is way colder, it does the freezing part much faster too. Brine takes 20 to 30 days to completely freeze the ground. Liquid nitrogen can do it in 5 to 7. In other words, it's great for emergencies or projects that need to be completed in a hurry. For example, it was used to help stop contaminated water leaks after the meltdown of the Fukushima nuclear plant in 2011. That sure sounds cool. So apparently, I am not allowed to end any of these segments by calling the application cool, because the pun is too unoriginal, and I used my one allotment in the title of this video. So freezing dirt is great, but what about getting the dirt on a criminal? Liquid nitrogen can help detectives do that too. You probably know how relentlessly a piece of duct tape resists your efforts to remove it, especially when it's stuck to itself, which is every time you try to tear a piece off the stupid roll. Well, sometimes crime scene investigators think there might be a fingerprint hiding between layers of duct tape, and retrieving it can seem pretty impossible unless you have some liquid nitrogen. For this, investigators can use a liquid nitrogen gun to separate the pieces of tape. And according to research from 2011, liquid nitrogen can help retrieve clearer fingerprints than either a chemical specifically meant to neutralize the tape's adhesive, or just angrily ripping the tape pieces apart. The researchers also noted that the results vary depending on how you apply the liquid nitrogen. For example, if you dunk the tape into a tank of liquid nitrogen, it does a good job at neutralizing the adhesive, but the tape can also become brittle. Using a cotton swab soaked in liquid nitrogen can work too, but you have to keep redunking your swab into the liquid nitrogen because there's only so much it can hold at a time, and the nitrogen will keep boiling off. So CSIs may need to refine the technique, but a little liquid nitrogen could potentially mean the difference between catching a bad guy or not. But it probably won't ever save you from throwing that frustrating roll of duct tape through your living room window. Moon dust might sound like something fun and fluffy for astronauts to lay down in and make the lunar equivalent of snow angels. But it's not. It's more like microscopic shards of glass that will shred your spacesuit fabric, gunk up your electronics, and airtight seals, and once you get back inside, get into your lungs. So after getting covered in moon dust, your first instinct might be to try brushing it off. But on top of all the damage moon dust can do, it's also super clingy. So not only will that brushing motion press those shards into whatever you're trying to clean, they won't really go anywhere once you think you're done. In fact, during the Apollo missions, that's exactly what happened. Some of the very expensive spacesuits were essentially ruined by moon dust. So when we eventually send humans back to the moon, we need to have a better better way for them to deal with it. And in 2023, researchers used liquid nitrogen to remove about 98% of that clingy moon dust from sample fabric swatches, including some worn by Barbie dolls inside a small vacuum chamber. And the liquid nitrogen washing method caused way less damage to the suits compared to the methods used by Apollo astronauts like vacuuming and brushing. The science behind this unique spacesuit laundry service is the Leidenfrost effect, which describes what happens when you place a cold liquid next to a significantly hotter surface. Some of the liquid vaporizes, creating an insulating layer of gas between the surface and the rest of the liquid. And when super chilly liquid nitrogen meets the moon dust resting on the much warmer, by comparison, fabric, the dust forms little beads and floats away. Now, the researchers weren't entirely sure how this works, but the liquid nitrogen sort of wraps itself around the moon dust particles, and as the gas expands during boil-off, it may cause the dust to become airborne. If this tech ever gets adopted, astronauts would hypothetically come back from a moonwalk, enter an airlock as per usual, and take a liquid nitrogen shower before doffing their helmets and suits and going about their moon business. And thanks to all that liquid nitrogen converting to gas, this shower would also help pressurize the airlock while the suits get clean. Yay, multitasking! There is one big caveat with this research though. It hasn't been tested in an actual lunar environment or with actual spacesuits or actual moon dust. And the team behind this research acknowledged that the moon's lower gravity and extreme temperature changes would probably affect how well this cleaning process works. But maybe they can do some follow-up research by flying a Ken doll up there to test it out, and then his job can be Moon Beach. Most of you probably didn't get to handle the containers of liquid nitrogen when you got that classroom demo, because yeah, you probably don't want a 12-year-old to accidentally spill a liquid that cold on their pants. But there is another pretty big hazard that comes with mishandling liquid nitrogen. As it boils and returns to a gaseous state, it will displace most of, if not all, of the oxygen in the area. And you might remember, you need oxygen to like breathe and stuff, and that's why if you're going to bring liquid nitrogen up an elevator, you have to put it in the elevator by itself, because if it leaks, it's not going to silently suffocate anyone. But maybe we can use this suffocation power for good. In theory, you could dump a buttload of liquid nitrogen onto a forest fire to starve it of the oxygen it needs to keep burning. In practice, this is challenging, because forest fires, as you might recall, are hot, and liquid nitrogen vaporizes at -196 degrees. Now, vaporized nitrogen could still hypothetically slow down a fire since it's cold, and it's denser than normal air, so it would sink toward the ground rather than automatically float up into the greater atmosphere. But fires also have hot updrafts that could mess that up. So it's better to keep any nitrogen fire suppressant in a liquid state for as long as possible. But how can you get it anywhere near the core of a massive forest fire? Well, back in 2016, some scientists proposed filling an aircraft with insulated, finned capsules of liquid nitrogen and then dropping them on the core of a forest fire from a safe distance. The fins would help the capsules spin in a controlled manner while they fell. And as they spun, they'd spray out some of their liquid nitrogen, kind of like a lawn sprinkler. The rest of the liquid nitrogen would be released when they smashed into the ground. To test their design, the team filled a prototype with water and dropped it from the top of a 17-meter-tall parking garage. The prototype spun as anticipated and dispersed some of the water, but not very much given the low drop height. In a forest fire, it'd need to come from like 200 meters minimum, and unfortunately, not much has been done to develop this tech for real-world use. But forest fires aren't the only fires that you can suppress with liquid nitrogen. Scientists have also proposed it as a quick and effective way to snuff out fires in enclosed spaces, from coal mines to utility tunnels to computer data centers. And speaking of hypothetical uses for liquid nitrogen, back in the 1980s and 90s, some people thought nitrogen cars were the future, mostly because electric cars, sucked back then. Do you remember the commuter car? No? Well, that's because it wasn't very memorable. The commuter car was an early electric vehicle with a maximum speed of about 56 kilometers per hour and a maximum range of about 64 kilometers. It did look a lot like a miniature version of the Tesla truck though, so I guess we've come full circle. Anyway, liquid nitrogen powered vehicles seemed pretty futuristic compared to the electric cars that were available at the time. And even today, there are researchers who think a liquid nitrogen car would be a huge improvement over an electric car. Because while electric cars don't produce emissions, they're batteries have environmental costs. They're made from toxic materials that have to be mined, and the energy used to charge them doesn't always come from renewable sources. So a liquid nitrogen car might make better environmental sense than an electric car, especially considering how they work. The engine would be very similar to a steam engine, but instead of boiling water to make steam, the engine's power would come from vaporized liquid nitrogen. The nitrogen vapor would turn the motor, and the exhaust produced would be nitrogen. And nitrogen isn't considered a pollutant because the stuff already makes up 78% of the atmosphere, which obviously makes them better for the environment than any gas guzzler. But how might they compare to modern EVs? Well, some researchers at Washington University claim that liquid nitrogen cars could match the performance and range of modern electric vehicles, and they'd be affordable and easy to maintain. They also noted that the demand for liquid nitrogen fuel could actually help reduce pollution, because to make liquid nitrogen, you start by sucking and compressing a bunch of air, and then that air has to get scrubbed to remove carbon dioxide. Of course, there are the usual safety concerns. You don't want to accidentally spill the fuel on you or try to fill up in a closed garage, and the fact that liquid nitrogen creates a lot of pressure as it vaporizes means there's some risk of explosion. Although you wouldn't have to worry about a battery bursting in flames, which you may have noticed has been a problem with some vehicles. But with all those hypothetical pros, why aren't we all driving liquid nitrogen cars? Well, it's complicated. Until recently, you needed an expensive heat exchanger to quickly vaporize the liquid nitrogen, so the concept wasn't very practical. And now that electric cars are pretty standard, it would be hard to woo the auto industry in a completely different direction. You know, again. So we might not be taking a bunch of air and turning it into a fuel for the next car of the future. But you know what we can do instead? Turn it into a different kind of energy source. Because sometimes green energy gatherers like solar panels and wind turbines generate electricity that isn't going to be used right away. This energy is often stored in batteries, but as we've established, batteries come with their own environmental downsides. So, as an alternative, scientists have proposed using that excess energy to liquefy air. Some of the energy is used to remove gases like CO2 and water that won't liquefy as the temperature drops. Instead, they'll freeze solid, so they're basically impurities. But after that little bit of cleanup, you use the rest of the energy to cool your air down until it condenses into a liquid, and then you hold that liquid in a vacuum chamber so it can't heat back up. To get energy back out of the system, all you have to do is let the liquid air warm up and turn back into a gas. That gas will be shunted towards a turbine, and using a fluid to drive a turbine and make electricity isn't novel at all. That's what most power plants out there are doing, whether they involve burning fossil fuels, splitting uranium atoms, or running a bunch of water from one side of a giant dam to the other. This technology has been tested in the United Kingdom, and plans are underway for larger plants that will be capable of storing significant amounts of energy. For example, there's a facility near Manchester that's currently under construction and should one day store enough energy to power 480,000 homes. So you see, liquid nitrogen has more uses than filling an hour of science class. It may be able to help make the world a little greener by putting out wildfires, replacing Teslas, and storing excess green energy. Though making ice cream is pretty cool too. We may have come to the end of the episode, but we haven't come to the end of blathering on about cool science, or the science behind cold stuff, because our spin-off podcast, SciShow Tangents, has another 38 minutes dedicated to cold. You can check it out by clicking the link in the description. Maybe grab a blanket and a cup of tea though. I'm already getting chilly just thinking about it. Thanks for watching.